Hello, fellow neuroimagers. Today we're going to talk about Zero Nine Lab. This one was a little bit confusing, so I'll give my best explanation on how to complete all the steps. That said, I'm not an expert using the FSL GUI either, so this might be interesting to see us walk through this together. First step, as always, is to cd into the UIowa lab course directory, labs.jdcat, and we will open up Jupyter here. Awesome. Click on Lab 9. Click on this. As you can tell, I already downloaded all the data, so I don't need to deal with that. And just to give a brief review, we are going to be talking about our second level analysis or third level analysis, whatever the group level analysis is, in order to get a group level statistic for our data. So some reviews and concepts, what information is reflected in the COPE files. And COPE, if you recall, stands for contrast of parameter estimates. And if it's a simple contrast, such that we have the conditions, say, incongruent and congruent, and we're just looking for the mean of incongruent, so it's just 0, 1. If I say congruent and incongruent, that would be a contrast 0, 1. And the contrasted parameter estimates would, in that case, be equivalent to the parameter estimate itself, or in other words, the beta values in the regression formula for, in this example, the incongruent trials. And then the varcopes are the variance of the contrasted parameter estimates. And then the spread standard. So in order to understand that, we need to think about how do we compare across participants. We need to often put them into a standard template space. So this spread standard helps us make that standard space, or put all the subjects into that standard space, so that we can do proper comparisons across them. So when we're looking in the hippocampus of one participant, we're looking in the hippocampus of another. Perfect. Now that we've discussed that, we'll skip over some of this stuff, and we'll actually just go right into the problem sets now. So we're going to load the group design analysis file above. So when we say above, that's what we mean. Open up a new tab here, cd09. Inside this group flanker feed directory. All right. So I'll add in code. We'll call feet. And we will load this design. Okay. And now we need to change some of the path names just so that we know where to go. This was designed on another computer, so these will be different. Let's check out and see exactly how they're going to be different. 795, so if I type print working directory, okay. It's in filtered feet, so I'll just cd into filtered feet. Print working directory. Select all of that, Control-Shift-C. And then go back to here. Control-V. And I'm just going to Control-V for all of these right here, and I'll just change the numbers. 95, 96. 97. Oh, so it says it wasn't valid. Suppose I'll have to deal with that. Some other point. I also want to change the output directory. And those are going to be given specific names. So I'll call this mixed OLS and 3 P.05. And this is the one that I'll work with first. It is interesting that it doesn't think that this is an actual directory. No, wait. Oh. It does it twice. Okay, so I must have accidentally copy-pasted twice, which would be bad. Okay, yeah, the directory looks a lot more reasonable. So I'm just going to do that again. Well, guess it doesn't unwrap. Okay. First I need to delete everything manually, and then I can paste. Okay. Now I'll change the subject names again. Great. Hit OK, still says it doesn't exist. And I guess I don't know what else I can do to change it. Oh. It went back to the... Okay. I'm gonna get this figured out. Sorry for taking so long with this, but this is some of the active debugging process and part of the reasons why I dislike GUIs. So I want this directory, I want to copy that. I'm going to paste this. Get rid of that, paste this. Get rid of that, paste this. None of this stuff. That's 95, 96, 97. But I actually still do need the filtered portion. So I'll copy this. See. Boom, boom, boom. Now hopefully that should work. Alright, finally. Whew. Okay, we got that to work. Now let's go to stats, and this is going to be our mixed effects with simple ordinary least squares. And I think this is all that we want for this one. So that all looks good. I'm going to hit save. And I'm going to save it in the example designs. I'm going to call it essentially the same thing that it is named as our output directory. So I'll call this our group flanker mixed OLS. Okay. If hit save again, okay, looks like it's been saved. Wonderful. So next we are moving on to just changing this to flame 1. And also changing the output directory. It's still mixed, but we are going to use flame 1. And everything else stays the same. Hit save. And we will save this one. As flame 1. Great. Now we are set up and ready to run both of these. Since the flame 1 is already set up and ready to go, I'm just going to hit go here. And that should start running for me. And it may take a little time. In fact, now that we've clicked go, going to load the other one. Next OLS. And I forget if they trip over each other if we try to run them at the same time, so I might just wait here before I click go for the OLS, the mixed OLS method at P of 05. But while that's running, we can take a look at what we are supposed to be answering. So which analysis method is more statistically liberal and why? So to answer this, it will be, they're both mixed, so that means they both include between subjects variation, but the ordinary least squares model, as opposed to the flame 1 model, if I recall correctly, and I may add a correction to this after I make this video, in case I'm wrong, that the ordinary least squares has to simplify and you can read that as homogenize the within subjects variances. So every single subject within the analysis has to have the exact same, well, is modeled to have the exact same within subject variance with ordinary least squares. Whereas with flame 1, we can have a different within subject variance. Per participant, if that wasn't obvious. So, which analysis method is more statistically liberal? I guess I would say the OLS method, because it doesn't quite account for the differences in within subject variation. It says it's still running. So let that continue to run. There aren't cluster statistics. So why aren't there cluster statistics for the analysis we ran with uncorrected p-values of p of less than 0.05? Because we'd have to select that we want to cluster statistics for that analysis. Oops, which actually I may have ran. So I was supposed to do that instead. So good note on those that caught me before that, that I didn't change that, but I should have. And it sounds like it might be done now. So we can look at the contrasts for the 3 people. Okay. And actually what I'm going to do is that I am going to make the change and rerun it. But just to be safe, I'm also going to delete the output. Which I thought the output was supposed to output here. Let's see, 509. Mixed. Oh, I didn't change everything about the output name either. Okay, so I guess we'll just change both and then we'll be good to go. So yeah, I should change that name as well. So yeah, we are off to a great start. That was just a little bit of sarcasm. But we are going to get us back on track here. I still do not understand why the copy and paste just adds on more text. There we go. So I have that there, and it looks like that this is going to be a valid output directory that is within our lab 9 folder, so I'll hit OK. And the post stats are uncorrected values of P05, okay. Now let's load the flame. Move that to uncorrected. Ooh, I don't know if I saved the last one. Okay. And then I will also change the output directory. Change it down here, it's all that really matters. 09 lab /. Looks good. So I save that. Okay. Let's go back and load the other one real quick. /09, okay, and then post stats. Oh, yep, didn't save it. So I gotta change it again. /09 lab, okay, so now that exists. I'll hit save. Make sure that I saved it. We don't need that anymore. We can close that. And I will hit go to just double check. Actually, I don't really care about time series plots. And save that again. There you go. Now this should output in the directory that we expect it to go. And we'll wait for that to run. All right. So to answer this question, there aren't any cluster statistics because we didn't run any of the options that would have required clustering. Because uncorrected means we aren't correcting for any spatial, any spatial correction or number of corrections. Describe in your own words how the fixed effects analysis we looked at in class differs from the mixed effects analysis you ran with respect to who results can be inferred to and what type of variance information is considered in the analysis. So fixed effects, again, as we heard in class, the only variance that we're measuring is within subject. So the mixed effects analysis also incorporates between subjects variance in this type of modeling. And that is the difference. So I think that's all. Is that all that I really need to say about that? That's all I'm going to say about that for right now. And we'll see how this is doing. It looks like it finished. Awesome. So that's uncorrected. We have some results that we can actually look at. All right. And this one was the OLS. So I'll load up the flame. I'll hit go for here. Now to run this one. We'll be well on our way to finishing the assignment. If I can get this long again. Okay. And the final thing that we need to do is do a hypothetical design. So suppose we ran 10 subjects in our flanker task. Each person was run under a condition of typical sleep and sleep deprived. Use the general linear model as we set up, or as we practice, to set up the design matrix that allows you to examine mean activation under each condition. Typical greater than deprived and deprived greater than typical. Use the example in the FSL docs to guide you. So I have that link to the FSL docs. Specifically, we're going to be looking at a paired two-group difference, so a two-sample paired t-test. And what we can see is that the first explanatory variable is marking the session. So this is the first session, second session, or the first condition and second condition that the subjects were tested under. So in our case, that's non-sleep deprived and sleep deprived. And each subject is going to get their own explanatory variable so that we can model the within subject variance as well as the between. And that is still running. But in order to set this matrix up, we do not need to let that stop us from completing this fourth problem. So let's see if we can come up with some logic here. We have 10 subjects. Each subject is going to have a 1. It's going to be a 1, 1, and a negative 1, 1. And that's going to be true for all of the subjects that we have here. So for the numbers, what are we going to have? So it's effectively going to be 20 long. So we're going to have to do that 20. So that's going to be 20 long, since we have 10 subjects. Each one has participated in a condition. Well, each of them has participated in both conditions. And then for each subject, we want to either have them be +1, 1, or -1, 1. And then the rest will be zeros. Oops, looks like that something happened. I actually tried to run the notebook. We accidentally did something there. Okay. So honestly, this one might be a little bit more difficult to code out. I'm going to pause the video here so I can ponder just for a little while, so that you guys just don't have to sit there and wait for me to finish thinking about how I would write this out, write this design matrix programmatically. Okay, I don't have it all worked out, but we will see what I can come up with. So how I'm going to tackle this problem is that on one end, we need to essentially check whether or not this is an even or an odd number, and that will determine whether we give +1, a +1 or a -1 for EV1. Yeah, that's what I was going for. And then then the subsequent EVs, we need to be considering on where we put the zeros. So for each 2 iterations, since we're going from 1 to 20, we need to be able to increment the zeros here. Okay. So I might need to reformulate how this goes. So for 1 and 10, so it'll now be for subject. And for cond, and let's list that out. Do that. Okay, so I think that will set us up to get that good. And then the post zeros, I'm going to do a print f, and I'm going to do back tab 0. I'm going to do that %.0s. I think that's how I need to format it. And I'll do that 1 to 9 times, since there will be a column of 1s that will be intervening with all these 9ers. So let's see if that intuition works. Just in the terminal real quick. So let's echo post zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, perfect. And then the pre-zeros is just going to be an empty string for now. Then for sub in 1 through 10, we'll leave that alone for now. And for this, we could either do modulo, or we could just say let's use the string comparison. Let's get some tabbing correct. Okay, so if con is equal to 1, then we will echo we want to allow tabs, so we'll do echo tab, well, echo 1 tab, then we'll print the pre-zeros, and then we'll print, okay. I just want to make sure that there's always a tab at the end. Or if it's a tab at the beginning, okay. So I put a tab at the beginning, tab 0. So that means there's always going to be a tab at the beginning here. I think that's how it showed out in here as well. Well, maybe not. I guess we will see whether the tabbing works out the way I expect or not. Otherwise, I'll just flank it with tabs. Alright. So pre-zeros. And then we'll need a post tab. I'll treat this one as the conditioned one. And then we'll have the post zeros. And then we'll essentially copy all this code again. Except if con is equal to 2, now we'll say -1. And I need to put some end if statements. So phi. And then finally I need to do the update step for the pre and the post zeros. So now I need to come up with a way that will get rid of 2 tab zeros from the post zeros and add them to the pre zeros. And I'm going to Google that because I don't know how to do that right quick. So I'll come back. Okay, I think I got it figured out. So while this probably isn't that big of a deal for our little 10 subject study, if we had 100 or several hundred subjects that went through this process, coming up with a little script to automate it would make it very nice. So pulling from some practices for doing for loops and some if statements, we can set up a little script to print out the design matrix for us. So I'll run it here so you can see the final output. Oop, forgot to fix this. Right. This is the final output. Again, it mostly mirrors what we see here, except the EV1, we just do every other, since that just makes it a little bit easier. Well, that's just how I structured it programmatically. I guess it doesn't necessarily make it easier programmatically, but that's how I structured it, is that for each subject in 1 through 10, I'm going to go through each of their conditions from what they were in. So then if their condition is equal to 1, then I'm going to print 1, which is standing for this one that we see right here. Then I'm going to put in the number of pre-zeros, which is essentially a place marker for which subject that we're on. And then I'll add the 1, which again represents this one right here. And then I'll put all the post zeros, which will be all the post zeros down out here. Now for the second time, it goes through this loop. It'll be equal to 2. So now I'm going to say -1, which corresponds to down here. And all the pre-zeros as their subject index. And then again, a 1 right here. Okay. And I'll print all the post zeros. And then the important update step, we want to decrement the number of post zeros there are and increment the number of pre-zeros. And then we'll actually print out how many zeros we need with a printf statement. And this expression is just something that I googled for repeating bash strings. And we can't use the same notation up here since we can't use variables within within this bracketed notation. So the next simplest solution was just to do sequence from 1 to that number of pre-zeros or post-zeros that we needed. So this is for pre-zeros, and then just to catch another base condition, I probably could have done this more intelligently, but just to catch the final base finishing condition for when post 0 num is equal to 0. So when we're at the very final part of the list, we print out a null string. Else we're just going to do the same thing that we did for the pre-zeros. And that's just to handle the final condition. All right. So with that, we can open up our GLM, go to a higher level design. We have 20 inputs, and we will have 10 EVs. And we are going to paste this. So first we need to clear all that. And I'll select here, left click, shift left click, Control C, click in here, Control V. I'll hit OK. And now it didn't quite work. So let's take a look and see if we can paste again. So let's see. I click right here, do Control C. I paste. And then it still doesn't quite work. Well, I'm guessing there's some representation that's going wrong between spaces and tabs, but oh no, I think I know what's going on. There needs to be 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that's what I was missing. Forgot to consider the actual pseudo grouping or session indicator. Okay. So now we should get what we wanted. Okay. Nice. And still, we would go through and name this a session, sub 1, sub 2, even 0 pattern. Sub 03, sub 04, 4, sub 05, sub 06, sub 07, sub 08, sub 09, sub 10. And now we can take a look back at the question. The mean activation under each condition. Ah. So I don't know if how I set it up would be let us observe the activation under each condition, but what we can do so if we look at this again, so we can look for differences between A minus B and B minus A. And that would be an easy way to do that. But in order to do independent conditions, we would have to do 0, 0, zeros, ones, 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 and then have another EV have be ones, 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 and 0, 0, 0, zeros. And that would allow us to look at the means for each condition if we weren't just interested in the how do you say in the if we weren't just interested in the contrasts. Okay, but since I spent the time coding the other one, I'm not going to spend the time coding what we should have done as well. So there would be 2 session columns. One would be for the sleep deprived and another one would be for the non-sleep deprived. And with that, it would be 1, 0. And the other one, it would be 0, 1. So maybe I could actually change that to pretty easily, maybe. Let's see. So then for each session, if it's one type of session, it's going to be a 1 tab 0. And for the other type of session, it's going to be a 0 tab 1. And now let's see how this works. Well, first I guess I got to get rid of this. I won't rename the subjects again. Get rid of that. And let's just exit that. Okay. So now we can get the answer that we wanted. Control C. Open up our GLM again. do higher level design. We're going to have 12 now, since each session gets its own EV. And still at 100. What's going on here? And this is going to be 20. And this is going to be 12. Now I'm going to paste it. Clear. I'll hit Control V. Hit OK. Alright. So now you can say that this one was normal and sleep deprived. So now we can get, for our contrasts, you can get normal sleep, sleep deprived, get those means. Then we can also do the two contrasts. So where is normal sleep greater than sleep deprived? So sleep greater than deprived. And where is deprived greater than sleep? So those would be our contrasts. And then we can save all this. Set our example designs. And then we can just call it, whatever we would want. We can call it the sleep design. Okay. I'm not sure which columns were causing that error. I suppose that they are all close to linear combinations of one another. Well, regardless, I'm going to ignore that error for now. And we'll call this design good for what the problem asked for us to do. And I think I have covered everything. We can just take a look at the results here for the mixed ordinary least squares versus the flame. So we'll look at incongruent for both of these. Looks like there's nothing. And it looks like there's something. So we can definitely see it here for the ordinary least squares. We see actual activation for the mean incongruent condition, whereas for flame, well, almost nothing is here. So OLS is the more liberal statistic. Okay, thank you for sticking with me on this one. This one was a bit of a long explanation. This video is a little bit longer than I expected it to be, but thank you for sticking there with me. And have a great day. Good luck on the rest of your assignments.